Welcome back, friends. Now we're going to talk about mechanical energy in detail. So mechanical energy, as we already earlier said, that it is equal to the potential energy plus kinetic energy. That's the formula. So we're going to try and learn about the mechanical energy in detail by taking an example. Let's say there is an object placed on the ground here. Okay. And this is, I'm going to call it as location 1. Here I'm going to call it as location 2. So this object, we wanted to slide this object up the hill in this direction. So this, to do that, I need to add up, let's say 100 joules of energy or work. Okay, both mean one and the same thing. So that's what we wanted to add. We have to do 100 joules of work onto the system. So right now this is moving here at this location, at location 1. This object was moving with 1 meter per second and I added 100 joules of energy. I wanted to find out, first of all, what is the total mechanical energy at this location, and the second thing I wanted to find out the potential energy at this location, kinetic energy at this location, and let's say this height given to me is, because I added 100 joules of energy, it end up reaching to a height of 2 meters. And this angle given to me, even if this angle is not given to me, I can see this distance. So this distance is given to me, let's say this is I'm gonna call it as 3 meters, or I'm gonna call it as 4 meters. That'll be better. So 4 meters. So at this location, at location 2, I wanted to find PE, kinetic energy, and mechanical energy. So if I can somehow find the potential energy and kinetic energy, I'll add those two values. That will give me the total mechanical energy of the system. So at location 1, first of all, at location 1, what is the mechanical energy? So, and this is an example of non-isolated system. Why this is an example of non-isolated system? Because I am adding the work into the system. So whereas in case of an isolated system, no work can be added, nothing can be taken out, nothing can be added into the system. So let's start with this question. So at location 1, what is the mechanical energy? You will say that the formula which you've been told is equal to the potential energy plus kinetic energy. So potential energy plus kinetic energy. What is the potential energy at this location? And I'm measuring everything with respect to this ground. This is the ground surface. Everything is measured with respect to this. So potential energy will be 0 because mg height is 0 in this case. So I'm gonna put the value directly here. This will be 0 plus kinetic energy. The kinetic energy value will be equal to half mv square, because the object is moving with a velocity of 1 meters per second. So there will be some kinetic energy. So this is 0 plus half times, I'm gonna assume the mass of this object is 1 kg also. So 1 times 1 square, which will come out to be 0.5 joules of energy at location 1. So that's what we figured out. Now I added 100 joules of energy. So mechanical energy, I wanted to find, first of all, the potential energy at this point. So potential energy at location 2 will be equal to mgh plus, oh, not, it's only mgh. So potential energy at location 2 is this, and mass value is again 1 times 9.81 times height value is how much? It is 2. So can I find the potential energy from here? So potential energy value will be 19.6 joules on top here. Potential energy is 19.6 joules. Now if I look into this system, this is 100 joules has been added into the system. Already system had 0.5 joules of energy. So total mechanical energy into the system, if I go on to the next page now, so total mechanical energy into the system at location 2 will be equal to, I'm going to go back to the slide and will again try to tell you. So this is 100 joules which is being added by me into the system. It was moving with 1 meters per second, so this is the energy which it already had. So total mechanical energy at location 2 will be 0.5 plus 100, that will be 100.5 joules. So if the total mechanical energy is equal to 105 joules, and this is also equal to potential plus kinetic energy. Now I figured out the potential energy in this case, which is equal to 100.5 joules. Potential energy out of that is, so out of that total potential energy at this location, 19.6 joules is being used to overcome this height. All right, so that will be equal to, so now this is equal to potential energy is 19.6, not 12. This is 19.6 plus kinetic energy. So 100.5 minus 19.6 will provide me kinetic energy value. So let's look into this. 100.5 minus 19.6, which will be 80.9 is the kinetic energy of the system. Let's say I also wanted to find out, I'm going to go extend on this question. I also wanted to find out what is the velocity with which this object is moving. So I can also find out that. So because the kinetic energy at location 2 is equal to 80.9, and we know the mass 80.9, we know the mass is 1 kg. So half times mv square equal to 80.9, and then half times 1 times v square equal to 80.9, and velocity value will be equal to 80.9 times 2, which will be 161.9, and if I square root this value, that will be velocity on top will be 12.72 meters per second. Notice in this question we haven't talked about the frictional the energy loss due to friction. So we are considering that it's a frictionless surface, no energy is being lost in the friction. So if there is a question in which you are asked, you're told that there is a friction also, so we have to subtract that also, but that's a topic for different class. So hopefully you are able to understand the concept of mechanical energy, and now in the next lecture I'll take some more examples on the mechanical energy. See you soon. Bye now.